what is the discharge and head loss of the same flow? We have to find out the two values, that is discharge and head loss. Discharge Q is equal to A1 V1. We know that because V1 we know from the previous question, so we are using A1 V1 or A2 V2 also we can use. For that we have to find out the V2 value. As we know A1 V1, so we are using A1 is equal to 4 width into depth is 0.2 Y1, V is 5.42, that is equal to 4.34 cubic meters per second, 4.34. So option B or option D is correct. In this head loss HL is equal to Y2 minus Y1 whole cube divided by 4Y1 Y2, that is equal to, by substituting the depths before and after jump, we can get the value of 0.64 meters. That is option B is correct. The question is, a soil profile is shown in the figure. If a uniformly distributed load delta sigma is applied at the ground surface. So if you see in the figure, a UDL is acting on the surface of 100 kilonewton per square meter, and the layers are sand and clay of 2, 4 and 4 meter respectively. So the unit weight is given, and the clay is having a void ratio of 0.8 and liquid limit of 40%. The water table is at the second layer top, that is 2 meters below the surface. So if you see the question, what is the settlement of the clay layer caused by primary consolidation if the clay is normally consolidated? So we have to find out the settlement. SC is equal to CC by 1 plus E naught into H log sigma plus delta sigma by sigma naught, that is equal to, sigma naught is the effective stress at the middle of the clay layer. Effective stress at the middle of the clay layer is equal to 2 into 14 plus 14 into 18 minus 9.81 plus 2 into 19 minus 9.81. We are finding the effective stress at this middle layer, that is 2 meter of the clay layer. So that implies 79.14 kilonewton per square meter of stress is acting at the middle of the clay layer. So if you see CC, we have to find out compression index. CC is equal to, we know the empirical relation, 0.009 into liquid limit minus 10 for a normally consolidated clay, that is equal to, if you substitute liquid limit 40 over here, that implies 0.27 cc. So if you substitute the values in the above equation 1, we will get SC is equal to 0.27 by 1 plus 0.8 into 4 thickness of the clay layer log sigma naught 79.14 plus delta sigma, external load is acting of 100 divided by 79.14, that implies 0.213 meters, that is equal to 213 millimeters. So option D is correct. The question is, what is the settlement of clay layer caused by primary consolidation? So we have to find out the settlement caused by the primary consolidation. The pre-consolidation pressure is given as 190 kilonewton per square meter. So which formula has to be used for finding out the settlement? So we know sigma naught plus delta sigma, that is 79.14 plus 100 from the previous question, 179.14, that is less than 190 kilonewtons per square meter, the pre-consolidation pressure. So for finding out the settlement, we can use CS into H by 1 plus E naught log sigma naught plus delta sigma by sigma naught, where CS is given as 1/6 of CC from the previous question, or from the data 1/6 CC we know 0.27, that is equal to 0.045. So if you substitute C is equal to 0.045 divided by 1 plus 0.8 void ratio, and H is of 4 meter thickness of the clay layer, log sigma naught is 79.14, delta sigma external load that is acting on the top from the question is 100 divided by sigma naught 79.14 from the previous question. That is equal to, the value comes to 36 millimeters. So option A is correct.